With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question, it is given that there is a parallel plate capacitor on which we are doing the following operation. Now in the P operation, we connect the capacitor to a battery of EMF V and then disconnect the battery. This is our operation Q. Then in R, we reconnect the battery with the reverse, with the polarity reverse, and then we in the S we insert a dielectric. Now we just represent this situation. Now let's say this is the first situation. So in this, we are having a capacitor and we connect it to a battery of voltage V. Okay, let's say the capacitance is C. This is our P. Okay, now in the Q, what we are doing, we are just disconnecting it, so it would be like this. Okay, this is our Q, and then in R, what we are doing in R, we are reconnecting with the reverse polarity. So that means initially this was the positive and this was the negative in the steady state situation. Okay, now this is positive, this is negative, but we are reversing the polarity of the battery. Okay, now this is our R, and in the final case, what we are doing, we just insert a dielectric. Okay, if we just insert the dielectric, so we need to check whether we are inserting it with a battery connector or battery disconnected. Let's say this is our S, and we have inserted a dielectric, so it would be equals to K. Now we are performing the operation. Now in PQR, okay, that means this, then this, and then R. The energy stored remains unchanged and no thermal energy is developed. Now in the A part, so we know that initially what would be the energy which would be given to the capacitor, which would be stored by the capacitor, it would be equals to, in the initial case, in the P, okay, so we can say that UP, this would be equals to 1 divided by 2 CV square. Okay, now this is the initial energy which the capacitor would be having. Now we have disconnected the capacitor. Now again we have connected it with a battery of EMF V, okay, or we can say that potential difference V. So again it would be charged. So the energy in case of our R, this would be equals to the initial energy which UP, the initial energy which it was having, then half CV square. That means the energies are not equal, so energy they would be changed. So A option is the wrong option. Now the charge appearing on the capacitor is greater after the action PSQ. That means P is this part. So we just represent our B. Now in the operation PSQ, if we check what would be the charge which would be getting. So in the operation P, the charge it would be having. So P, it would be, the charge would be equals to C into V. Now after this, in the situation S, we have inserted the dielectric. Okay, now if we just insert the dielectric, then what will happen? The charge would become, or so we need to consider that it is basically inserted when the this battery is connected. Okay, now when battery is connected, potential would be same. So the charge in the situation of S, it would be equals to, because the capacitance would be increased by K times, so it would be K into C into V. Okay, because the capacitance, new capacitance would be C, Kc, but the voltage would remain same, because in this situation basically this battery is connected, so potential would be same. Now after Q, so in the Q situation we are disconnecting the battery. That means till S we were having the battery, now we have disconnected. So this was our S, and in our Q the charge would remain same. So this we say that Q, it would be K C into V. Now in the operation P, then Q, and then S. Now in the operation P, first of all we just write P, then Q, then S. Now in the P operation, the charge P, it would be equals to C into V. Now in the Q operation, we have disconnected the battery. Now if we disconnected the battery, the charge would remain same. So we can say that in our Q, the charge in the situation Q would be equals to C into V. Okay, because this charge which initially it would be having, it would be an open circuit, charge cannot flow. Now in the S, what now we are doing? We are just inserting the dielectric into this. Okay, if we just insert the dielectric, what will happen? Because we are not changing the potential, okay, because we are not changing the potential of the capacitor, charge would remain same even though we just insert the dielectric. So our charge in S situation, it would be C into V. Now what will happen? We just write here. Now if we insert a dielectric, when the battery remains disconnected, the charge would be constant. We should remember this. Okay, charge would constant, but our potential decreases, but charge would remain constant if the battery is disconnected. Now that means B is correct, because that capacitor, this dielectric constant K would be greater than 1. Now the energy stored in the capacitor is greater for the process SPQ. Now in the process SPQ, so what would be the energy in the C case? SPQ. Now initially we can say that in the process SPQ, first we insert the dielectric and then we connect it with a constant this potential. So in this situation, what would be the energy stored? We can say that in this formula, we can say that energy stored could be set to be half the capacitance into V square, or we can say that C dash. Now because we have inserted the dielectric in the process S, so we can say that we have increases the capacitance, but the voltage would be same. So that means U would be directly proportional to K. Okay. Now in the next case, what we are doing P and then Q and then S. Now if we just check here, now initially this is our P, that means the battery was connected, and then after that we are doing Q, that means we are removing the battery, and after that we are inserting the dielectric. Now in this situation, since battery is disconnected, so the charge would remain same. Now if the charge is remaining same, that means in the other process we can say that we will be applying this formula, Q square divided by 2C dash. Now the U would turn out to be Q square divided by 2K into C. That means our this U would be inversely proportional in the second case. This is the first case, this is the second case. U is directly proportional to 1 by K, or we can say that U is inversely proportional to K. Clearly this would be U1 would be greater than U2. So we can say that energy in the process SPQ would be greater in the process PQS. So C is also correct. Now in the D process, now we need to find about the electric field. So first P and PS. Now in the case P, we have already connected it with this with the constant voltage source. Okay. Then we have inserted the dielectric. Now the battery terminal, or we can say that the voltage supplied by the battery would be same. So we can say that for the process P and S, voltage would be equals to, we can say that potential difference would be equals to V. Now in the process SP, we have inserted the dielectric, but again we have connected to the same battery. Then we can say that voltage would remain same. It would be equals to V. That means D is also correct. So the correct option are B, C, and D. Hope you understood this solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.